All right, we're good.
Great. Welcome all HackFS hackers in this session and anybody watching along on YouTube to another session focused on Lotus. Today, or rather this afternoon, for this session, we have Aayush, Filecoin engineer, and Why, the technical lead for Filecoin. They are going to be walking us through a workshop specifically focused on how to use Lotus in your own personal project. So we're very excited to have them. And it's building off of some of the other sessions we had today, which was Pooja earlier, talking about developing a Filecoin. And then we had Vasa just a few hours ago talking on other ways to build with Lotus. So if you missed any of those sessions and you want to look at them in context with this one, which you're in right now, definitely go check them out in the ETHGlobal YouTube channel. And we'll keep going with the awesome content. Logistics, I'm sure most of you have heard this or already done your check-ins, but go to your cohort channel. We're running the first week, or rather the first check-in for week 2, which is something that we're going to be doing throughout the entire event for the next few weeks. We do just a simple text-based check-in. So you go to your hacker dashboard and write a few small details about what you're working on, any issues you're having, any specific sponsors that you plan to integrate, things like that. It's helpful for us to help you resolve any issues, and it's helpful for the rest of the HackFS community as they're building things. They can see your progress and you can help other people. So make sure to do your check-ins within the next few hours. We hope to have all of them done within 24 hours, and then we can kind of start building and helping people with different resources. Karate says, I don't see a check-in channel. I would hit me up on Slack and we'll figure out which one you're supposed to be in, because there are different ones. I think that's it for logistics. I'll let Aayush start and share his screen.
Cool. Yeah, thank you very much, Trent. Thank you, everyone who's participating in HackFS and attending this workshop in particular. Very excited to be doing this. Today is very much intended to be kind of like an interactive follow-along process. So definitely try to keep up with what we're doing. Feel free to ask questions on chat or just unmute, especially if you're running into trouble following those steps.
Sorry, I forgot to mention, we try to do this every session, but if you are blocked or you have an issue or a quick question, don't be afraid to unmute. This is meant to be an interactive workshop where you can learn and be able to follow along. So if you do get stuck, just jump in quick, and we're more than happy to help you catch up.
Cool. All right. Sorry, I can be heard well, right? By the way, I should have checked that. Oh, excellent. Yeah, so we've got this very quick intro deck, but and after that, Why will be taking it away and kind of just doing a live demo of how to get set up with Lotus. I'm assuming familiarity with Filecoin by this point, by the people that are attending. So today's focus is definitely on Lotus, which is the reference implementation of Filecoin. The website for docs, as well as just most of your resources will be lotu.sh, lotu.sh, as we like to say. So if you haven't already, please go there. Let me also quickly drop a link to this gist that you may already have. It was sent out in the kind of prep materials, but that's the rough outline of what we'll be trying to follow along today. So keep an eye on that as well. Very quickly, what is Lotus? What is a Lotus node? What does a Lotus node do? Kind of like these are the 6 big points. Lotus is what will help you find everyone else on the Filecoin network and connect to them. Based on those connections, figure out where the blockchain is at and then sync the chain as required. And then it provides a bunch of tools to interact with the blockchain itself. This is kind of your standard Ethereum things to send messages, query chain height, all of that fun stuff. Lotus provides an internal wallet for key management, so you have an easy way to manage your keys, sign messages, and so on in there. And then obviously specific to Filecoin, Lotus provides interfaces to actually store and retrieve files from the network itself. Kind of a subset of Lotus is the miner itself, which can be run as a separate process. It's designed to, the miner talks to a Lotus node to submit block-setted mines, but it is not a core part of a Lotus node itself. So if you just spin up your Lotus node, there's no mining related stuff that's going to start automatically, which is good for people that aren't miners. So today, this is kind of what we have in the gist as well. Basically, Wai is going to be sharing his screen. How do you install Lotus if you haven't already? How do you get it up and running? We'll be using the Nerpanet chain, which is a HackFS network that we have. And then we'll essentially just be playing around with Lotus so that people can get a feel of what it's like to work with Lotus. So we'll use the CLI, maybe we'll use the API. If there are specific things that people would like demoed, we're more than happy to do it. If not, we have some kind of key features to highlight. Last thing I'll say is this is intended to be very interactive and flexible. So like I said, feel free to ask questions, feel free to direct this yourselves. I'll try to keep an eye on questions coming in on the chat, but as Trent said, feel free to unmute and ask questions as well, because that's kind of what we want to do today. But that's about all I have to say. Wai, if you want to take it away.
Cool. Give me that screen share.
Oh yeah, I guess I have to stop doing that first.
Yeah, I can't steal it from you.
Ah, there you go.
All right, so I am just going to be sharing a terminal here for a bit. Can you all see this? Good, great, cool. So Lotus is in itself a CLI, program. The entire interface is really just through the CLI, where you have separate things that are, GUIs on top of it and other things that build on top of this. But for the purpose of this workshop, we're just going to be hanging out in the terminal for a bit, looking at some cool text. So first thing, once you have Lotus cloned, so I did a git clone, github.com. I ran this already because I have slow internet and I don't want to bother doing that live. So you run that, it'll clone down Lotus, and then you're gonna cd into it and you can just run make Lotus. And this is just gonna go through, and the build process is actually like a little more complicated than a normal Go project because we're binding in a bunch of Rust code. Lotus is mostly Go, except for all of the proofs and crypto stuff is in Rust. So our BLS signatures, our snark verification, our snark proving, all of that's in Rust. So it has to do a bit of downloading some Rust stuff and then binding that into Go and so on. So from here, I'm gonna open up a Tmux. No, I don't have Tmux, are you kidding me? Sorry, new laptop. This is embarrassing here.
That's fine.
Outing myself.
Quick interruption to say that folks following along should check out the NTWK-Nerpa branch that's in the list.
Oh, Nerpa, right. Sorry.
Yeah. Oh, yeah. You want to do that as well, Jeremy.
Should I get over to Nerpa? All right.
That'd be a good idea. That'll just make sure that you automatically connect to the Nerpa network, which is the HackFS network.
I don't even have my git aliases on this computer. This is all right. So I'm gonna have to run make Lotus again. Yeah, so with Lotus, we tend to bake in the Genesis block and the Bootstrap network configuration into the code. So when you check out a branch and you build the code for that branch, it's going to have the network to connect to pre-configured. So now we have Lotus, and we have a binary. You can just run /lotus or equivalently lotus -- help to see the sets of commands we have. The way we design applications here, we try to make sure that you can explore the full set of capabilities from the command line. So for example, lotus state -- help gives you all the Lotus state commands. And so from here, you can see Lotus state power -- help. And you can go through and explore like, oh, what are the set of things I can do with Lotus Node? And we have a lot in here because we use this tool to debug and diagnose the network in general. So like all of our debugging and all of our like to figure out what's wrong with the network work tends to result in features being added to the CLI interface to help with that. So the first thing you'll want to do is run Lotus daemon. This is just like any blockchain network going to kick off the daemon and start syncing the chain. Actually, I need to get into tmux first. So have the daemon running. And so while it's running, it's, you can't do anything else in that terminal. So you're gonna have to open up a new terminal to do other things. But we can check a few things. So we can check Lotus sync status. And this is gonna tell you that we have one of our sync workers doing a header sync. The height that it's syncing at is 23,685. So that's how many blocks there are on this network. And we're syncing the header chain from the tip that it's discovered all the way back to Genesis. Once we've synced the header chain all the way back, you can see that this number of height is going down. Well, maybe it seems like the network's maybe a little slow, or my internet's kind of slow, actually. Once we make it back to Genesis, then we're going to sync the messages and validate the chain. The reason for syncing the header first is so that you don't, you verify that the chain actually links properly so that people can't DOS you by creating fake chains that you then try to sync and download massive amounts of data and resources to verify. So a few things to check here. While you're syncing, your chain head is not going to update. So when I run Lotus chain list, which is a command you can use to list the chain, you're just going to see the Genesis block. So this is, block 0, created on July 6th. That's its CID. It was mined by 00, which is just meaning that it was created by like the Genesis system itself. So nothing here is really going to change. And so for a while, because, well, syncing the network, at least on this code, is probably going to take about half an hour to 35 minutes. I don't really feel like sitting around waiting for that to happen in front of everybody. So I have another node. I'm always paranoid about typing my password on live Zoom calls here. But so I have another node, and I think it's synced. Let's make sure. Yep. So this node is synced. So when you run Lotus chain list on a synced node, you're gonna see a lot more information. You can see each line, which gets wrapped on my screen, is going to show you the chain height of a block, its creation date, and then the set of blocks, the CIDs and miners of each block in that tip set. So it'll show us, I think, about 30 by default. And then we can check a few other things. Lotus sync status is going to tell us, so sync status kind of gives you an idea of more of the inner workings of what Lotus is doing. So the Lotus syncer has 3 workers that are just open to any tasks. So as blocks come in, it'll schedule one of those workers to work on syncing this block. This is more diagnostics information, but it can be useful if you're wondering, why isn't things syncing? So we can see these are all complete. So onto some fun stuff. So the Lotus state command is where a lot of the interesting, like what's going on in the network stuff is happening. So one thing we can do is just run Lotus state power and see that this network has 16.7 terabytes of power on it. So it's not a huge amount. This is a small DevNet, so fairly normal. We can do Lotus state list miners. Looks like there's about 15, 20 miners in here. And then, so this is like the set of miners that you have that could be creating blocks here and are just generally on the network. You can check the power of any individual miner, like how much storage they're providing to the network. And so, like, for example, if you're building an application that wants to like select a miner for making a storage to deal with, well, you could list all the miners and then go through and see which one has the most power. It's potentially a useful heuristic, probably not the only one you want to use. What else do we have? Oops. So you have Lotus Wallet. So the Lotus Wallet command is basically your in-node key management set of commands. So I can, I can list my existing addresses. I have this BLS address here. The very long addresses that start with T3 are a BLS address. I can create a new BLS address. And so now when I list them, there's 2 of them. I can also create a secpk or secp 256k1 address, which are much shorter. So the reason we have each of these BLS addresses or BLS keys, when you sign messages with them, their signatures can be aggregated. So the actual cost to the chain of using a BLS address is much less because we just aggregate all the signatures and you save like 90 bytes per message of signature data. And actually, a simple BLS message to just send funds from one account to another can be as small as 20 bytes, which is really cool. Like, if you think about how Bitcoin has like a block size limit of like 1 megabyte, if you fill 1 megabyte with 20 byte transactions, that's a whole lot of transactions. It's like 500,000 or no, 50,000, I think. Is that math? Something like that. I don't even know. No, it's more than that. I'm really bad at math. Aayush, do the math.
Yeah, I think 500,000 was right.
Was it? Okay, cool. Yeah, so Lotus Wallet balance allows you to check what the balance of your default account is. You can also check the balance of anything on the network here. Like I can pick this new thing, oh, that's my same address. This new address I made here, that's 0. The secp address I made has 0. So just some other simple commands. Lotus send lets you just, as it says, just send funds from one account to another. So let's say I want to send this account 5 Filecoin. Great, sent that. And it's going to tell us the CID, the hash of the message that it sent off. So now most Lotus commands, instead of waiting for for a message to land on chain, it's just going to tell you what the hash of the message is so you can wait on it yourself. So what we can do is we can do Lotus state wait message and give it that. And so this is going to scan the chain to see if it's already made it on chain. And then if it hasn't found it on chain, it's going to wait for new blocks to arrive. Aayush, how long is this going to wait by default? It's going to be like 4 minutes, isn't it?
Yeah, 4 to 5 minutes, I think.
Yeah, I don't really feel like waiting that long on a live, workshop call, but that's how you do that. It also exists as an API call. It's like most of these commands map nearly one-to-one with API calls. So you just call wait message in your app and wait for the callback to fire.
Yeah, I'll quickly add that there's a whole bunch of, for those who prefer visualizations of things, there's a whole bunch of community-run dashboards that you can look up things like your message CID or your address on, and it'll just provide that information. There aren't any for Nerpanet, which is the HackFS network, but the kind of bigger, stabler testnet, the big one with 20 petabytes of data, supports all of those. So when you kind of graduate onto that network, you'll be able to visualize it as well.
I just sent more money. Okay, yeah, it's not going through yet because it's going to wait for like four or five confirmations. Cool. So that's some basic commands. You create a wallet, send some money, check your balances. But Filecoin is really about storing data. So let's make a file to store. So I'm just going to type in this file. And I'm going to copy and paste it a few times just to make it above 120 bytes. There's a minimum file size in Filecoin right now. I don't think, we don't necessarily pad it out for you. So if you try to store a file under 128 bytes, it's going to tell you, actually, that's too small. Like that's basically smaller than the hash that you're using to talk about the file. So you might as well just, put your data in a message and throw it on chain or something. So we have our file. Make sure it's there. Look, Aayush, do you have a miner ID that's good? I think we have a miner running.
Yeah, give me 1 second. I believe it was just loading.
So the Lotus client subcommand is what you're going to use for interacting with the markets, both retrieval and storage markets. And so the flow of making a deal in Filecoin and storing data in Filecoin is first you need to import the data. So Lotus client import will let you take the path of a file, and it's going to take it, do some processing on it, and give you back its hash. Now this is almost identical to an IPFS add. So if you're familiar with IPFS, this is basically IPFS add your file, which is kind of cool because Filecoin stores IPFS data, and like our default native format is just IPFS data, packed into a car file, but So we grab this, and then now we are going to. Oh, first I should probably query the miner. So Aayush, did you find a miner address?
Yes, I sent it to you on Slack, but 01023 should be good. Or at least worked last night.
Great.
And Travis says it's still running.
Cool. So here's our miner, 01023. So this very short address here. Every account on Filecoin gets what's called an ID address. ID addresses are assigned a number, and that's basically the order of account creation globally on Filecoin. So the cool thing about blockchains is you have a total global ordering of everything that has happened on the chain. Obviously, you have to wait for some number of confirmations before you can be sure there won't be a reorg, but you do get a total global ordering. And so what we're doing is every account has a normal address, like your long hash address or something along those lines, but it also gets assigned to the short ID address. And so with your accounts, instead of using passing around like your giant long Ethereum hex address or whatever, you can just say, oh yeah, I'm 1047, right? Or something along those lines. And that's much easier to remember, much easier to pass around and like share, but it also takes up much less space on chain. So instead of being 30 bytes on chain for an address, it's 5, 6, even when you have millions of addresses. So really, really space efficient here, and also like memetically easier to remember. So we have queried the ask, which is the storage, storage information, and like basically what this miner is willing to accept for payment of a storage deal for this miner T01023. And so they're saying their price per gigabyte is this, their max piece size is 512 megabytes. That's because they're a 512 meg miner. Miners are able to set both minimum and maximum piece sizes, so they can say they don't accept files smaller than X or bigger than Y. And there's a few other parameters that they can advertise, but really a miner gets to decide themselves if they accept your file or not. So there's nothing obliging a miner to actually accept your deal, even if you pay them like infinite amounts of money. So with that, we're going to make a deal. So the deal command has a few extra flags around here. Most of these you don't usually care about, but for example, you can manually specify some hashes of things so that we can pass. So instead of transferring the data over the network, you can, for example, mail a miner a hard drive with your data, because moving terabytes of data is hard, to say the least. So Lotus client deal, we're going to grab our data CID from here and put that there. And then the miner is T01023. The price is this price that we got from here. And then the duration, let's say that we want to store it for 1,000 blocks. I think I have enough money for this. Yeah, so there is our deal. And this is the CID of the deal. So now Lotus client list deals is going to give me, oh wow, nice wrapping there. But yeah, so Lotus client list deals is going to show me, it's just going to make it ugly if I move it out here. Oh well. So the deal CID The deal ID is 0. The provider is 1023. This is currently in deal client funding, which means that the deal is waiting for us as the client to put money on chain in order for the deal to actually be funded. So the miner actually hasn't accepted the deal yet. The miner is waiting for us to commit money to the chain so that the miner knows we have the funds to actually pay them. So this means this is not on chain yet. Obviously hasn't been slashed yet if it's not on chain yet. The piece CID is another hash I'll explain in a second. This is 2 kilobytes of data, and that's the price and duration. Actually, oh, sorry, it's not duration actually. That's like ending block height, I believe.
So you're proposing it at the miner's ask? Is that what we're doing there?
Exactly. I'm just proposing it right at what the miner's asking for.
Okay.
So you could try to set a lower price, but I think the default logic says reject. Miners are definitely able to write their own, logic for accepting things. So like if they have a sector that's just about to be sealed and it, has a little bit of space left over, they might accept data at a lower price, just to fill out that deal so they can have a nice, perfectly packed sector. Or, depending on the size of the file, like if you want to store one whole sector size of data, they might give you a bit of a discount just because that's logistically easier for them. So there's a number of different things that could happen here. So
just very quickly, in case anyone was wondering the obvious, when Jeremy made the deal, the price was 0.0 with many zeros followed by 5 because that was in Filecoin, kind of the higher level unit. What's being displayed under storage price there is an atto-fill, which is just 10 to the 18 Filecoin.
Yeah.
10 to the 18 Filecoin. That's all. Hence the difference.
Yeah, we have some UI work here to do around. We use the same amount of denomination as Ethereum. So if you're familiar with Ethereum's, what did they call their tiniest unit?
Way, I think.
Way, yeah. So this number down here is effectively in way. We're using metric SI units, so we just call it atto-fill because that's 10 to the negative 18. And yeah, ideally we would have like a little units attached to that. I think we should make a note, Aayush, to print things in nicer.
We have an issue open for it.
Do we have a workshop scheduled for the whole mining process of sealing, setting up, starting up at all? Is there going to be a workshop planned for that?
Not that I know of, but we could do one.
Yeah, that would be awesome.
I can also switch to showing some miner commands, not setting up a miner necessarily, but the machine this is running on is a mining machine.
Oh, that's awesome. What's your specs, man?
It's a Threadripper with a bunch of RAM.
You got the NVMe for the swap and all that?
Yeah.
That's awesome.
It's got all the things. But back to our deal. So it says storage deal validating. So now the miner storage deal validating means the miner has received our data, and now they're validating that deal is correct. Actually, I wouldn't expect to see it stay very long in this. Also, everything, each step right now has a confirmation, I think, of 5 to 10 blocks. So between each of these phases, it's 2 to 3 minutes just because things are being waited for to land on chain. A lot of this is because I haven't actually made deals with this client before. So once you already have money locked up in the market, that first step of waiting for client funding would have gone through immediately because I would have already had funds in the market. And likely this miner is just waiting to see a bunch of these things.
That's a good point to maybe just ask for questions. If people are confused about anything or want elaboration on anything, feel free to post in the chat or just unmute.
Well,
cool.
So yeah, so while we wait for that, I can go through some other interesting commands here. A fun one, like one of my favorite commands on Lotus is more of a diagnostics command. So Lotus state, compute state. What it does is it allows you to compute the state root for any given tip set, which on its own seems pretty boring. And it is kind of boring on its own. But what you can do is you can specify any tip set at any height. So if I want to go back to tip set 2000 and compute the state for that, you just type in at 2000 there, and it's going to give you the state. You're like, wow, well, that's cool, but what the hell do I do with state root? Great question. The fun thing here is that you can show the execution trace in this super not ergonomic format here. Which, okay, so this is slightly more interesting. There's a bunch of numbers and a bunch of addresses. What's really going on? What's really going on is this is every message that is being sent and in every invocation trace that's happening on chain. A much more interesting way of viewing this is we have an HTML format here. Oops. Yeah, some HTML format there that is, I'm gonna share that because I think it's pretty cool. I'm gonna have to share my browser now. Okay, so this is, I think, actually really interesting sort of stuff to look at because it kind of helps you understand what's going on in the block. This block itself actually has contains no messages, but there's still a bunch of stuff that happens every block. So even if there's no messages, you're still going to award the block reward. In Filecoin, the block reward is awarded by the miner in their block. They include a transaction that calls award block reward on the reward actor. So there's a specific actor, like smart contract in Filecoin, that holds all of the funds that will ever be paid out to miners. And every time you mine a block, you get to call redeem. And so that goes through. So we call reward actor award block reward with some parameters saying this miner is claiming a block reward. That's going to go call add locked funds, and it's going to lock up this amount of money, which right now on this network, the block reward is 1.8 Filecoin per win. This is just a weird kind of random number just because the crypto economic stuff is not yet finalized on this network. So 1.8 Filecoin is not the actual block reward. That would be absurdly low. And then, so there's a few, so we can see that this upper level method is calling down to add locked funds, is calling into update pledge total, and then it goes back and then it sends zero. Well, actually it's kind of a bug. We shouldn't call this if there's no Filecoin to burn, but it burns any account fees. So if there are fees that happen potentially in each block, and if there are fees, we burn them. I think we missed a check for if there are 0 fees, don't bother sending a message.
Yeah,
Aayush, you want to write that one down as a...
Will do.
Cool. So we can see that there are several award block rewards. This tip set contains 1, 2, looks like 3 blocks. So I'd expect to see 3 different block reward awards. This one for miner 1002, this one for miner 1000. And then we have a cron tick. So who's familiar with like cron in a Linux system? So cron in a Linux system is like, it's a daemon that you can tell to do something at some certain time of the day. So you can say like, run this command at 5 p.m. every night, and it'll just do that. And so in Filecoin, we have a cron actor, which allows things to be scheduled to happen at certain points in time. Right now, we have this closed so that only system actors can register events, but in the future, this will be open up to user programmable contracts to be able to register stuff to happen in the future, which is a really nice feature because being able to say, I want this to happen, in a week, and just run this code in a week on chain have like an autonomous computer being running that for you. It's really cool. So the built-in cron ticks kind of do a few things to maintain like network KPIs. We track we track like how much block rewards given out every round so that we can adjust to pledge collateral and so on. And then there's a few other things that happen. But the main point of this is if you're ever curious to see, like, I sent a transaction on Filecoin and it didn't work for some reason. You can pull out the tip set that transaction ran in, pull up the trace and look and see in depth every single step that happened to try and figure out why that command failed. So for example, if you're running a miner and some miner operation failed, you're like, why did this happen? Well, you can dive in and go see what happened with Lotus compute state. I'm gonna stop sharing my browser. And go
What's
back
a tip set? Like, I read about it and you just gave me a trace of a specific tip set of a certain block height. What does that actually mean, if you don't mind me asking?
Yeah, of course, that's a great question. So most blockchains, you have one block for every epoch, right? So Bitcoin, you have one block, it mines on top of its parent, which mined on top of its parent, and so on and so forth. In Filecoin, at every round, there are a number of blocks that get created, and all of them are included. So they're all like valid blocks at that height. So we target this to be about 5. So we try to have around, on average, 5 blocks per round. And this is a result of expected consensus, which is our proof of stake-ish algorithm that we're using for storage-based consensus. And so a tip set refers to the set of blocks that occurred at a certain round that were mined into the chain. So a tip set at height 2000 is the set of blocks that were mined at height 2000 and were included in the main chain.
Yeah, the concept of a tip set also has one interesting consequence for how messages are included and executed, which is in, say, something like Bitcoin. If a message is included in a block, it's executed in that same block because you can just do that, and the result of that execution happens kind of immediately. Because you have multiple blocks in a tip set, it's possible that multiple blocks at the same level will include the same message. So you can't actually execute the blocks right away. So instead, what happens is messages are broken into 2 stages, inclusion and execution. So messages get included in blocks at a certain tip set, and maybe they're included in 3 out of 5 blocks in that tip set. They'll actually get executed in blocks that are built on top of that tip set, so child blocks of that tip set, and only get executed once, because at that stage you can deduplicate based on if you have multiple copies of the same message.
Yeah, so the actual concept of a state root in Filecoin is always referencing the parent state root. So for a given block, you know that block's parent state root. And that's because when you create that block, you're selecting the set of parents that you're mining that block on top of, and then you serialize all the messages in that block in order, deduplicate any messages that are duplicates, and then run through that execution. And this allows us actually to have a fairly high level of throughput, because you can actually, if miners properly coordinate and properly include like different sets of messages, if every block in a tip set includes a completely different set of messages, you can have 5x the number of messages that get executed at a given epoch. And so this is, yeah, ready?
So yeah, you said there was multiple. You can have multiple parent blocks.
Mm-hmm.
And the math they're performing is going to be on each of the ones where their message is in each of those parent blocks. Is that what you said? And I don't want to take a lot of time in this detail, but I just want to get the general idea.
Yeah. So every block includes some messages, right?
Right.
And so when you're mining your block, you pick a set of parents that you're mining on top of, which are blocks from the previous round. Those blocks have to be all at the same height. And so you include those, and then when you're computing the state root to base your block off of, it's going to be the result of computing all the messages in the parents that you chose.
I'm just repeating that in my head. It makes sense. And so I was imagining the math that was required to take the messages computed from each of the multiple parent blocks and then creating a combined, block of, it's the result root state.
Yeah.
Yes.
The parent state root. Yep.
Yeah.
You also know we're not talking to miners right now because y'all then asked the question miners immediately do, which is, does every block in a chipset earn a reward? And the answer is yes. Every block in a chipset earns the same reward. It's not split out across the miners, just in case you were wondering.
But if we do our job right, the coin value, it should get cheaper and cheaper, right? If Filecoin, spreads to the entire world, right, it should get cheaper and cheaper. Like that's our goal, right? Not to, anyway. Like we're not looking for coin appreciation. Never mind. Like this, we're gonna get it. Like this is gonna like a tastes great, less filling argument, probably.
Yeah, something like that. Oh yeah, our deal is now sealing. So we made a deal with the miner. It was accepted, and now it says storage deal sealing. So what this means is that that miner is taking our deal. They've packed it into a sector, and now they are sealing the sector, which is the process of proving it so that the network can guarantee that my data that is in that sector is guaranteed to stick around over time for the time that we agreed to. So the miner now is like working, computing that proof. They'll post it to the chain once it's done. And then at that point, really at this point, from this point onwards, I can know that my data is pretty safe. But once the sector is actually sealed, the miner will be severely punished if they drop that data. Well, severely punished as in they lose all the pledge collateral and all the deals for that sector. So this is basically, I have certainty that my data is there and I can walk away and be fine. And eventually this will change to storage deal. I don't think it says complete.
That's active, I'm pretty sure.
Active, yeah, storage deal active. So that just means that my data is being actively stored by this miner. Yeah. So Aayush, what else is interesting to go over? We stored files, that's Filecoin, right?
That's Filecoin. I think it's worth talking about multifigs real quick and maybe payment channels, just because they're nifty tools. Pick one, I don't know which one's more exciting.
Yeah, let's talk about multisigs. So for people who are not familiar, a multisig wallet is an account that requires multiple different people to approve transactions in order to send. So you can have some number of people that are allowed as signers and then some number of required signers. Various different systems implement this different ways. Bitcoin implements multisigs as a threshold signature. Where you, with your message, you include multiple different signatures. There's even trickier systems that use like BLS aggregate threshold signatures, which just require one signature for your whole setup. Or there's the more Ethereum style where you have a contract where you send the signatures to the actor or smart contract in Ethereum to propose and approve transactions. So Filecoin's multisig operates similar to how Ethereum multisigs work, where you have your account, one person proposes a transaction that shows up on chain, and then approvers can then send their approvals to the chain. So for example, you could have a multisig that has three signers and say 2 are required. So like if that's me, Aayush, and Trent, then I could say, I propose this transaction, and either Aayush or Trent could look at that and say, all right, I approve that. Once they approve it, the transaction goes through, and then the spend happens. Whatever it is that you want it to do happens. So this allows you to do better custody of funds. So we have this command that allows you to control those somewhat easily, where we can create a multisig. This has basically, you can pass how many signers are required. A default of 0 is really bad. We should probably change that because that just won't work. The value, so this is how much is the initial funds that you're going to give this multisig. And then you can specify a sender, which is like, what account of mine am I using to create this? But that's not necessarily an account that will be a signer. So let's grab some addresses from my wallet here. And then we'll do Lotus msig create required equals 2. And then we'll pass on these 3 addresses from my wallet. And this is one of those fun commands that actually waits for the multisig to be created before returning. So this is sent a message to the chain. it's going to basically create this multisig. It's going to get the output of creating it, and then it's going to tell me the address that was created instead of giving me the transaction hash that was sent. So
yeah, that creates an address on chain that requires transactions signed by both those private keys then.
So this creates a multisig on chain that requires signatures from 2 out of these 3 addresses. So any 2 of these addresses can spend money from this account on their own.
Oh, so it's N of M. So yeah, I got it.
Yeah, it's N of M. Yep. So it's 2 of 3 in this case, where the 3 is implied by the number of addresses I put down. Yeah,
Could you do 2 of 2?
Confirmations.
Could you have done 2 of 2?
Yeah, you can do 2 of 2. You can do 1 of 1,
Cool.
1 of 10. It's fairly arbitrary.
0, so maybe let's change that.
Yeah. Blockchain confirmations are exciting.
We did get some requests for payment channels, so if you want to switch to that.
Okay.
The last 10 minutes.
Yeah, let me kill that. So just like everything in Lotus, we have a nice command for interacting with whatever feature of Filecoin we want. So Lotus page for a payment channel allows you to get, which gets or creates a payment channel to a certain person from a certain person. Actually, let me go back.
What is a payment channel?
What is a payment channel? Yeah. So a payment channel is effectively a way for you to pay people in a way that they can trust that they receive the money without hitting the chain. So at a high level, what you do is, for example, if I want to pay Aayush a bunch of different times, say, we have a certain agreement where I'm going to pay him, money for every time he does a thing, but I don't want to pay transaction fees for each of those 1,000 things. So I'll lock up 100 Filecoin to Aayush in a payment channel. Aayush can see on chain that money is locked up so I can only send it to him. I can't double spend it to anybody else. And then what I can do is I can create vouchers that are signed by me and sent to him that say, I owe you 1 Filecoin. And then I can make another one that says, I owe you 2 Filecoin, or I owe you 3 Filecoin. And I can just keep sending him a new voucher every time I want to send him more funds. And as long as he holds that, he can cash it in on chain at any time. But he doesn't have to. He can wait until he's certain that he's not going to receive any more and then cash it out, so that he doesn't waste transaction fees and space on chain by cashing this out every single time. So this allows you to do nice off-chain payments while you can still trust that the funds are going to be there, because you could just send somebody, you could create a transaction, sign it, and send it to somebody, and they'd be like, oh, good, I could spend this transaction on chain. But the problem there is that it doesn't prevent me from sending that money to somebody else. And so the nice thing around a payment channel here is that you can guarantee that the money can't be double spent. So the commands for it are pretty straightforward. We have the payment channel get, which allows you to specify a from address, a to address, and amount. So let's just go ahead and create one of these real quick. Which of my accounts has money in it? Is it that one? No, it's this one. That, and then we'll make it to this, and we'll put 4 Filecoin in it. Why did that return empty, Aayush?
I do not know.
I haven't used this command in 3 weeks, so maybe something's funky and we should investigate it.
Yeah, it sounds like it.
Okay, so, Lotus payment channel list lets you list the payment channels you have registered here. So since I'm a miner, this is like my miner node, these payment channels are going to be payment channels that are made to me, likely. Let's see, Lotus state get actor. yeah, so this is just a payment channel that's to me from somebody else, and it has a little bit of Filecoin in it. Likely this is somebody who has stored data with my miner and is trying to retrieve it. So when you retrieve data, we pay, you use payment channels to pay for data retrieval so that you can pay somebody a little bit of money, they can send you a little bit of file, and you can go back and forth sending them little bits of money in exchange for little bits of file as a way to avoid the problem of like sending you all the money up front and then not giving you the file or vice versa. And so we use payment channels to make a more fair retrieval market. So all these channels are likely just people retrieving from my miner. God, we should add another command that lets you just inspect. We don't have an inspect payment channel command.
A good point.
But yeah, payment channels are at least in the CLI, the more lesser used thing. So we haven't been paying as much attention to them. So this is kind of good UI feedback that we're just walking through this and being a little, oh no, there's not that much to show here.
Yeah. Does the concept of payment channels make sense to people though? Because it is a little subtle, but I feel like for me personally, when I first got it, I was like, this is really cool. So if you have any questions, now's a good time to ask.
So they are designed to use in any way that a developer can think of. It's not just to be used internally for retrieval deals or anything. Okay.
Yeah, the payment channels can be used for anything. There's actually a number of different things that we have set up. So one of the cool things we have available, the payment channel has a lot of functionality built in. So one example, you can create a hash lock payment channel where I can send you a voucher that you can cash in only if you know a secret. And so with that functionality, what you can do is I can send you money. I can send you, say, a voucher for 10 Filecoin that's locked on some secret. And then you can send me, for example, a similar payment channel of Ethereum for, say, 20 Ether that's locked on the same secret. And since you can make that, since it's a hash of a secret, you're saying if you know a value that hashes to this, you can spend this. You can create that payment channel to me with the same secret. And then if I want to spend the money that I got from you, I have to reveal the secret on chain, which reveals it to you. So we can have a trustless way to exchange tokens between any two networks. So I could send you 10 Filecoin locked like this. You can send me 20 Ether locked like that. And then we can reveal the secret and both cash out, which is a really cool thing. We also have the ability to have the payment channel, when you try to cash it in, call some other actor on chain to check something. And the one notable use case we have for this right now is you can create a payment channel that is the voucher that is valid if a particular miner's sector is proven. And then from there, you can say, okay, Aayush, I'm going to give you 10 Filecoin once this sector is proven, and then I'm going to give you everything you need to generate the snark for it to prove it. So I can pay Aayush to compute a snark proof for me and submit it to the chain in a trustless way that he knows he's going to get paid if he does that work, which I think is really cool. It allows us to build like off-chain markets for various mining operations and things, and obviously like a whole host of other potential things that are there.
Very cool.
Yeah, we're at the 5-minute mark, so probably good to just take last-minute questions. But also, I have an update from Travis that I believe your deal has sealed. Jeremy, if you want to status. Travis is the info person, by the way, that I keep referring
nice.
to. Keep running that
storage deal active.
Just to know, we can go over a little bit. That's all right. I'm not sure if we had an hour or an hour and a half set for this. Maybe I scheduled it a little short, but if people still have questions or there are additional features you guys like to go into, that's totally fine. If you have a hard stop, that's also fine as well. But I think it's important for people who aren't able to attend to view it afterwards. It's super helpful for them. So carry on if you can.
You have to retrieve the file. Jim says you have to retrieve the file.
To retrieve the file?
Yeah,
okay.
you must. Otherwise, it's not a complete test.
That's totally fair, because retrieval always works 100% of the time and there's no problems at all.
All right, so I'm going to delete this file. I I just deleted the file. It's sealed into a sector. I should be able to trust that Filecoin, has my data. Oh, and the other thing, when you import it, when we do the client import, it imports it into your local block store, just like an IPFS add. So I think if we look here, we can see that the file is still here. So we have to do. Oh, did that command not land in this?
That's not in Nerpanet yet.
Oops.
You can just retrieve it from a different node, though. If you have, you can retrieve it from the one that you have syncing.
Do I still have a node syncing? No, I killed that.
Oh.
Well, let me show you what it would look like. It's going to pull it locally, and it's not going to be actually impressive, but we'll do it real quick.
We might have commented at the local retrieval, so we'll find out.
Oh, well.
So we did comment at the local retrieval, so it is actually.
We did comment at the.
Yeah.
All right. So let's. So now what's happening is it's contacting the other miner. The other miner is going to have to unseal the data, I believe. So when packing right now, the way that the proof of replication works is that the time to seal the sector and the time to unseal it are about the same. Future proofs of replication will not have this trait, but this was the most secure POREP we could come up with in the time. We have other constructions that are better than this, but this is, provably secure where the others are questionably secure, and we don't want to have to delay mainnet anymore, but to wait on a new proof that may or may not be right yet. So right now, unsealing a sector takes as long as sealing a sector. So we're waiting for the sector to be unsealed.
That's going to be a long time.
Yeah, so these are 512 meg sectors, and I think
so
Travis was saying, I think Travis was saying this is about 8 minutes right now. But in the latest Lotus code, we have miners by default will just keep an extra unsealed copy around if you ask them to. So you can tell a miner, hey, I'm going to pay you a little bit extra. Please keep a copy of this file unsealed around, or at least keep it readily available so that you can retrieve it to me. So if you want to be able to retrieve your files quickly, you can pay a little bit extra so that they can keep an extra copy. If not, you have to wait, Glacier style for the data to be taken out of the archives, which is the default in this particular version.
Is my perception of this correct, that there's not yet kind of like a market around retrievals? Like there's no way to browse like retrieval prices and choose who you want to retrieve from. It's just kind of happening black box right now, right?
Yeah, right now it's happening kind of black box. There's not a good market for it yet. So this is the retrieval client that's built into Lotus is the worst possible retrieval client. It basically you either have to tell it exactly what miner to retrieve from, or it just retrieves from, oh, well, that's angry.
So whoopsies. I think
what happened there.
That's a similar failure to one that we have an open issue for. So it looks like we have some work to do.
Yep. Anyways, as I was saying, the retrieval client built into Lotus is the worst possible one, as evidenced by this error here. The protocol itself is very, very flexible and just supports paying arbitrary people for arbitrary data. It's really just a protocol for paying people for giving you data. And so with that, there's a lot of more interesting things that can be built. We can build aggregator services that track BitTorrent tracker type setups where people keep track of who has what data and how much the pricing information is. You can have clients broadcasting data they're looking for and have people compete to offer that client a low price. Any number of these things can be built. It's just not in the Lotus client at this point. So better retrieval clients are in progress by various different groups in the community too. So yeah, the Lotus implementation is not a good showing.
I think the general philosophy of things are designed to be actively, built, improved on, and innovated upon applies to large chunks of Filecoin. This is a particularly good example of it, and we're really hoping that a lot of that kind of like layer 1 type improvements will happen, potentially from folks on this call or participating in HackFS.
Cool. Anybody else have any more questions? Just kind of open the floor for anybody who's curious to just ask away. Anything you're curious about, just let me know. Y'all are so quiet.
Yeah.
So quiet.
That means you covered all their questions.
We have answered every possible question.
There are no unknowns left.
Yeah, in all seriousness, definitely ask questions here. I think you also have good Slack channels and other venues. I'm sure once you're up and running with Lotus, you'll run into all kinds of problems or just things that you're not certain about. Definitely bring them to us, because we want to get those questions answered, those improvements made, just improve the overall experience.
Yeah, definitely. If there's anything you run into, any troubles, feel free to just ping us in Slack, the Phil Lotus channel, or Phil Help. We watch a lot of the different channels, so. And feel free to also tag us in discussions if you want our input.
We had a question from someone named Juan Bennett in the chat that says,
oh, geez.
I think many applications people are making will be best built with payment channels. How can we get demos of all the different ways of using them?
Good question. We can put together some different use cases and examples, and maybe build like a showcase sort of idea. Juan, did you want to say anything about this?
Yeah, I think it would be pretty. It's pretty important to show. I mean, you started demoing it, but then you stopped halfway through. I think it's pretty important to give people a view into how those actually work, because most of the applications people are writing are going to require them, or at least a lot of them will.
Yeah, I think putting together a little tutorial, like text tutorial, and adding a bit more UX support around this will be helpful.
I think people are going to need them like this week. So can we get an ETA on when we could get that?
Yeah, we'll work on that. I'd like to learn more about how payment channels are written to the main chain. Docs, yes. Yeah, so we'll work on some docs, hopefully today or tomorrow, obviously as time allows, but yeah. Yeah, okay, so there's lots of payment channel excitement. Great. Aayush, we have our work cut out for us.
Yeah, sounds good. No, payment channels are definitely exciting, so I'm glad to see the response. And as Jeremy already said, they've kind of gone underused or interacted with so far. So we'll put some time into them.
Yep.
Awesome. If there are no final questions, comments, clarifications, we can probably wrap up there. And it seems like we're good. Thank you so much, both of you, for demoing all this very useful resource.
Yep, thanks for attending, everyone. Have fun. Stay safe. These are crazy times. Feel free to ask questions. And yeah.
And we'll see everybody in the Slack. Be sure to bring your questions or clarifications there. Happy hacking, week 2.